Hey, this is Shyam Verma. I'm going to briefly explain like what I did in this data challenge. So first of all, I imported a JSON file into Pandas data frame, and I looked at the data frame information to check whether how many missing values we have. And so first first thing is that this data set was having 29,389 records, and some of the variables and some of the categorical variables were having missing values, as we can see in this root date, region, and uh, time from average. These fields are having missing values. Even success is having missing values, but that is a part of problem statement that we need to for the missing values of success, we need to predict the outcome. So further doing in our analysis, continuous variable statistics, when I looked at the results, it was showing lot of outliers. If you see, for example, in area population, the max value is 1832, while the 75th percentile is 41, and mean is 26. So this is clearly an outlier. And same thing, box plot on the right hand side is showing the outlier values which needs to be treated. So for treating outlier values, I will show in the code like what I did. I used interquartile range for treating the so this was the import code. And after that, when I looked at this, so for treating outliers, I wrote this function where it was calculating quantile range between q1 and q3 and IQR, and then the upper range set was Q3 plus 1.5 times of IQR. So what I did for these two fields, whenever the value was greater than the upper range, then I was putting the upper range. Like this is the capping, like this was the max cap I was putting on both the variables. So that is one thing. Then after that, I plotted these graphs. I can show in the code. I plotted uh, these graphs to analyze if there is any significant variation we can see across different levels for these categorical variables. But since in our data the success records are too high, having one, and the records having zero are like very less, so it was very difficult to analyze or to conclude anything from these charts, like what factors are significant and what factors are not significant. So what I did, uh, I went ahead and performed chi-square analysis. So you can see chi-square contingency cross-tab tables I plotted for different variables. So it was showing that this is the statistical value, and the second value you see, this is the p-value, and this is the degree of freedom. So p-value, like whenever p-value is less than 0.05, we can say that that variable, both these variables are having significant association, and we can consider those variables in our model. So that I have put results, summarized results on the slide. You can see that some of the variables came as significant, are having significant association with the dependent variable. Now moving ahead for continuous variables. So for continuous variables, what I did, I modeled those using OLS method. So that I can show in the code here. If I go down, yeah. So this was the OLS method in which I created a list having the continuous variables list in this, and then uh, I performed a OLS model with the success, and I plotted the results. So in the results, you can see the p-values which are significant as per these results. So yeah, so I went ahead and like check the correlation among these variables, because all these variables came uh, significant. So there may be like these variables are highly correlated among each other, and if we use them, then it may result into multicollinearity. But when I ran the correlation on all these numeric variables, I could see that all this like correlation is very low. Like these variables are not highly correlated among each other. So that's one thing. The next thing what I observed that some of the variables like having large values, and some of the variables are having like smaller values. So for that standardization was required. So for that I performed this standard scalar on these numeric variables, which I'm going to use in my model. So this is that, and then after that, let me go to here. Okay, so in the code I can explain the modeling part. So this analysis data I created, um, so I created a subset of the data named analysis data here in the code, where like success was not null, and I created one target data where success is null. So these two data sets I created, and after that I did standardization using standard scalar for numeric variables in both the data sets. This is the analysis data which I'm going to use in model, and this was on the target data, which is our final prediction data set, like in which we need to do prediction. And after this, x and y, in y I got success dependent variable in x. After creating dummy variables, like dummy variables, as we know that for categorical fields, in this, like suppose bad weather is having yes and no. So those are the string variables. So for using string variables in logistic regression model, we need to do one hot coding. So for one encoding, we need to do get dummies. So I used get dummies, and I use draw first equal to true, because if we don't use this, then it will create two flags, one for yes, one for no. But since these two flags will be like 100% correlated among each other, because if one is zero, the other one is one, or vice versa. So that's why we use draw first equal to true. Because of this, it will not create unnecessary variables. And then I concatenated it back with the uh, our scaled data set. Then after using this, when our x and y data sets are created, then I use train test split. I split it 30% in the test and 70% in the train for model development. So train will be used for model development, and test will be used for the validation and checking the accuracy of the model. So this is sklearn standard library logistic regression, which I used to predict, and for fitting on the X train and Y train, and checking the accuracy of the model. I calculated a score on the X test, Y test. So this gives us 96% of accuracy. Okay. Okay, so this is this log model decision function. This I used because this was one of the requirement to plot ROC curve. So for plotting ROC curve, I first got a Y predicted, and then these are the two, logistic FPR, logistic TPR. So FPR, this is false positive rate, and TPR true positive rate. So that I'm getting from this function ROC curve y test and y predicted. So y test is the actual values in our test data sets, and y predicted is the our predicted values. So based on that, it calculates the false positive rate and true positive rate. And using this, like, I plotted this AUC curve, as you can see. So AUC curve is something like, if we just random generator will be a straight line at 45 degree. So whatever it is gaining above that is the model performance, because if our model is not predicting anything, it will be straight line. But whatever area it is covering above it, that is the prediction. So 74% is the prediction. Uh, so then I performed this model prediction on our target data set. Like, I got y target equal to log model dot predict x target, and then I uh, assigned the predicted values in the column of the target data. And since in the submission I need to submit anon ID and success, so I wrote those into CSV. Yeah, that's it. So thank you.